Okie dokie, guys. Welcome back. Today we're going to wrap up Chapter 4. We're also wrapping up this second quarter. That means that this is the end of what's going to be on the midterm exam. So you can expect everything from Chapter 1 all the way to Chapter 4 to be in the midterm exam. So let's go ahead and wrap this up. Today we're in 4.7. We're talking about sequences and functions. And I know that you guys have been witness to sequences a lot in your life, especially with video games, believe it or not. Bless you. Let's say you're playing a video game, and every time you get whatever, a gold coin, or you beat up a criminal, or you capture whatever you're looking for, you get a certain number of points for it, don't you? So for example, let's say every time you get the gold star, it's 100 points. Aren't you adding 100 points to your total every single time? It's increasing by 100, then 100, then 100, then 100. That's a sequence, by the way, guys. That's a sequence, okay? A sequence is an ordered list of numbers that often form a pattern. And each number in this list is called a term of a sequence. Okay? It's a term. So when you have a sequence of numbers, a list of numbers, any one of those values is called a term of the sequence. Now, there are two types of sequences, guys. We are going to be working with arithmetic, okay? We are going to be working with this one. But I want to teach you both just so you know the difference and you know what to look for, okay, to give you more knowledge. So an arithmetic sequence occurs when you are adding the same value repeatedly. It does not matter if that value is positive or negative. The definition of an arithmetic sequence is a sequence that is formed by starting with an initial value, okay, the first term, and adding the same value repeatedly, whether it's a positive number or a negative number, okay? A geometric sequence, which again, we're only going to see a little tiny bit of geometric, but I want to explain the difference. A geometric sequence is when you multiply the same value repeatedly. Now that number that you're multiplying could be negative, it could be positive, it could be a fraction. Whatever it is, though, has to be multiplied repeatedly to itself over and over and over. So an arithmetic sequence, again, you find because you add the same value repeatedly. A geometric sequence you find by multiplying the same value repeatedly. Does that make sense, boys? Okay, now, let's go ahead and look at an example. I'm going to teach you a procedure here, guys. This is not in the book. It's a very good and easy procedure. It's a good way to find whether or not it's an arithmetic or geometric. I'm going to tell you how to do it. Please follow the directions. In the other classes, people want to do it their own way. That's fine, but it's not as efficient as my way. So I suggest strongly you follow my directions, please. Okay, so we want to describe each sequence, excuse me, and then we want to find out what are the next two terms of the sequence. Now, remember there's two types of sequences, guys. An arithmetic that is adding the same number over and over and over, and a geometric sequence that is multiplying the same number over and over and over. So how the heck do we test? Okay. Our first test will be for arithmetic. When we do this test, remember, the answer that we get here must be added to everything repeatedly. So to test for arithmetic, you go second term minus first term. To test for geometric, It's second term divided by first term. Again, the answer to the arithmetic must be added repeatedly. The answer, if it's a geometric, must be multiplied repeatedly. So let's go ahead and test them out. If it works for one test, you do not have to test the other one. So for example, if you test for arithmetic and it is arithmetic, that's it. It's arithmetic. You do not have to test for geometric. So let's test for arithmetic. Second term is 8 minus first term, which is 5, which is 3. If this is an arithmetic sequence, I'm going to be adding 3 to every single term, and it should give me the right answers. So what's 5 plus 3? What's 8 plus 3? What's 11 plus 3? Perfect. So this is arithmetic. Okay. What are the next two terms? 17 and 20. And now, describe the pattern. When we describe the pattern, it's not just naming it arithmetic. That's naming the pattern. But describing the pattern, you would follow the following procedure. Start with 5 in this case, because that's our first term, and add 3 repeatedly. That's how I want you to describe this. No other way. I want it described like that. So, first thing, we test to see if it's arithmetic. If it works, great, we're done. If it doesn't, we test for geometric. You can name it, either arithmetic or geometric, and then you have to actually describe it. And that's describing it. Yes, sir. In this particular case, it did not say to name it, so no, we would follow directions, but I'm just letting you know the name of this would be an arithmetic, sir. But according to our directions, which I always tell you to follow, we would not have to name it sir. Thank you. Okay, let's check the second one, okay? B. Let's do our first test. What's 5 minus 2.5? Okay, remember, we're testing our first one for arithmetic. So if it's an arithmetic, I'm going to add 2.5 to everything and it will work. What's 2.5 plus 2.5? Okay, so far so good. What's 5 plus 2.5? Whoa, is that going to work? So, no, it's not arithmetic. Let's check if it's geometric. Second term, which is 5, divided by first term, which is 2.5. What's 5 divided by 2.5? 2. What's 2.5 times 2? 5. Works. What's 5 times 2? Works. What's 10 times 2? Works. What are my next two terms? 40 and 80. So since the second test worked, this is a geometric. Again, you don't have to name it in this particular case. But man, now you have some more knowledge. And then how would you describe this? Start with 2.5 and multiply by 2 repeatedly. Okay? Does that make sense, guys? Promise? Okay. Does that make sense? All right. Let's continue then, please. Okay. My first test. Second minus first to see if it's arithmetic. 11 minus 5 is 6. What's 5 plus 6? Plus 6. Plus 6. So this works. It is arithmetic. What are the next two terms? 29 and... How would you describe this sequence? Yes? Start with 5, correct? And add 6 repeatedly. Very good, son. Very good, son. Excellent. How about D? Let's do our first test. What's 200 minus 400? Negative 200. What's 400 minus 200? No, 400 minus 200 is not negative 200. What's 200 minus 200? 0. Is that what we have for the third term? So is that arithmetic? No. So now we got to do our second test. 200 divided by 400. What's 200 divided by 400? 1/2. What's 400 times a half? What's 200 times a half? What's 100 times a half? So this is geometric, and this would the pattern here would be start with 400 and multiply 1/2 repeatedly. Does that make sense, boys? Oh, sorry. The next two terms in this sequence would have been and 12.5. Thank you for following directions. I apologize. Thank you. Yes, sir. Because with the question was, why didn't you say start with 400 and divide by 2? Because I had said that with geometric, we're multiplying by whatever value it is. So yes, in essence, you are dividing, but isn't multiplying 1/2 the same thing as dividing by 2? But with arithmetic, you're adding whatever value it is. And with geometric, you're multiplying whatever value it is, whether it's a positive, negative, or a fraction. Okay, let's do our first test. You're welcome, son. Thank you. -4 minus 2 equals -6. What's 2 minus 6? Huh? Okay, what's -4 minus 6? What is -4 minus 6? -10. So does that work? No. So we're going to have to test for a geometric. What's -4 divided by 2? -2. What's 2 times -2? Times 2, -2? Times -2? Works. What are my next two? 32 and -64. Very good. So I'm not going to write it down because we got to move on, but it would be geometric. And for E, it would be start with 2 and multiply by -2 repeatedly. Yes. Yes, if there's a time that they both don't work, then you simply put not a sequence. Thank you, my brother. Okay? Now, first test, -11 minus a -15. Please be careful with that example. It's not -11 minus 15. It's the second value minus the first value. So it's -11 minus -15. What's -11 minus -15? +4. What's -15 plus 4? -11. What's -11 plus 4? +4. So does, no, -3. So does this work? What are the next two terms? 1 and 5. So this would be arithmetic, and you would describe this function by saying start with -15 and add 4 repeatedly. Does that make sense? All right. Now the rest of the lesson I think is really easy. So we had just talked about arithmetic sequences. I already defined it, but we're going to just make sure we put it all together now. In an arithmetic sequence, the difference between the terms is constant. And this difference is called the common difference. Remember, when you do your first test, that's the common difference. That's what you're going to add to every single value. So for these next examples, we want to see, bless you, tell whether the sequence is arithmetic. If it is, what is the common difference? So we do not have to test for geometric anymore. We're only testing for arithmetic because that is what we are told to do. So this is going to be a lot easier and a lot quicker. So my test will only be the number 1, arithmetic test. 8 minus 3 is 5. What's 3 plus 8? What's 3 plus 5? What's 8 plus 5? What's 13 plus 5? Does it work? So yes, it is arithmetic. What's the common difference? 5. This is the common difference, guys. When we find our test, that's the common difference. You guys with me? Yes, sir. We've already said that. Then it would be not an arithmetic sequence and not a geometric sequence. Thank you, sir. Okay, let's do our test here. What's 9 minus 6? What's 6 plus 3? What's 9 plus 3? Oh, that's not 12. So this is not arithmetic. Let's do our test. What's second term minus first term? What's 15 minus 8? What's 8 plus 7? What's 15 plus 7? What's 22 plus 7? So that does not work. No. Last but not least, let's do our test. It's 9 minus 7. What's 7 plus 2? What's 9 plus 2? Plus 2? So this works. So it's yes. What's my common difference? 2. Sir. No, not unless it asks you. According to this example, it just said tell whether it is an arithmetic, and then if it is, tell me the common difference. If I wanted extra terms, I would say find the next 2 terms. Thank you, sir. Does that make sense, gentlemen?
Yes, sir.
Promise? Okay. Now, I can put all of this, guys, into a formula. Okay, I can do arithmetic sequences using a formula. And this is very helpful because let's say you know a sequence, right? But you want to find the 80th term. It's kind of hard to keep adding 80 times, right? Over and over. It just takes a lot of time. So there's a formula that was created to go ahead and help you figure out any term number. And if you want to find the 50 billionth term, you could find it using this formula. So remember, A of n is the output. That's the dependent, okay? All A of n means is the nth term. So like if you say, I want to find the 15th term, that's what an is, okay? That's the nth term that you're looking for. A1 is the first term of the sequence. So if you're going 2, 4, 6, 8, 10, 12, 2 would be your first term. N, this n in here inside of the parentheses, that's the term number. That will equal the nth term. So if I want to find the 15th term, then I'm going to need to use term number 15. And then minus 1 in parentheses, and then D is the common difference. Excuse me. So go ahead and write that down, please. And then we'll do some practice problems on that, please, and thank you. Oh, I already have it there. Okay, cool. So AN is the nth term, the term you're looking for. A1 is the first term of the sequence, plus parentheses n minus 1, where n is the term number that you're looking for, and D is the common difference. So, let's get on this. It's not that bad. An online auction works as shown below. Write a rule to represent the bids as an arithmetic sequence. What is the 12th bid? Okay. The item that we're bidding on is an electric guitar, and they tell you that the minimum price is $200. So the first bid has to be $200. So we have bid 1, $200. Bid 2 is $210. Bid 3 is $220. Bid 4 is $230. Okay? They want you to write a rule for this arithmetic sequence because it is arithmetic sequence. When you're writing this rule, you're going to need simply, 3 pieces of information. First thing you're going to need is n. What term number are we looking for? Read, guys. What term number are we looking for? What is the 12th bid? So isn't that the 12th term? You with me, guys? Next thing you have to know is A1. What's your initial term? What's your first term? 200. And the last thing you need to know is your D, your common difference. What is the common difference here, guys? 10. Do your test. 210 minus 200 equals 10. So now we are ready to rock and roll. Let's just fill in the blanks. So A of 12, the 12th term, equals the first term 200 plus n, which is 12, minus 1 times 10. See how easy that is? Once I just find my 3 pieces of information, I literally plug them in. I evaluate. And now I want to know the answer. So my 12th term is going to be 200 plus 11 times 10. That's 110. So it's going to be $310. If they wanted to find the 75th term, they could. Whatever term number you want to find, you can find using this formula. Does that make sense, gentlemen? Promise, sir? Thank you. Remember, A1 is the first term. AN is the term number you're looking for. A is the value of the 12th term. It's the value of n. Okay, the value of n. It's the value of the 12th term. Yes, sir? No, I will never give this equation to you again. You're going to have to memorize it. Okay? For example, let's check the next one. Thank you for asking, by the way. Okay. Let's just reduce this a little bit. Okay, a subway pass has a starting value of $100. So check it out. A starting value of $100. After one ride, the value of the pass is $98.25. So starting, then this is my first term. After 2 rides, my value is $96.50. After 3 rides, it's $94.75. Write a rule to represent the remaining value on the card as an arithmetic sequence. What is the value of the pass after 15 rides? Okay? How many rides can be taken with the $100 pass? So, okay, we got to find 3 essential things here. First of all, what's my n? What's the term number we're looking for? 15. What is my A1, my first initial term? 100. Now, what is the common difference? Let's do our little test. What's 98.25 minus 100? Okay, guys, it's so sad that you don't know how to do that. When the signs are opposite, you subtract as normal and keep the sign of the largest absolute value. It's going to be 175, guys. I don't know why you keep saying 2. I don't know why you keep saying 2. It's 1. Negative 175. So that's negative 1.75. So now my formula is going to be A of 15, my 15th term, will equal A1, which is my first term, plus n minus 1, which is 15 minus 1, times negative 1.75. Does everyone see how I filled in that equation? Does everyone see how I filled in that equation? Does everyone see how I filled in that equation? Okay. I'm hoping that you're being honest with me. So now let's find the answer. So A of 15, my 15th term is going to equal 100 plus, okay, 14 times negative 1.75. So I've got, let me erase this. So I've got 14 times negative 1.75. And it's 14 because 15 minus 1 is 14. So 0, 2, 0, 3, 7, skip, 5, 7, 1, 0, 5, 4, 1, 2, 2 decimals. Okay, so 2450. And that's going to be negative, so plus a negative 2450. So my 15th term would be 100 minus 2450, which would be 75.5. 75.5. Does that make sense, guys? Now, for part B, this part right here, how many rides can be taken? How much does each ride cost? $1.75, right? So how would you figure out how many rides you can get on $100? Huh? Divide, yes. 100 divided by 1.75 roughly gives you 57.14 roughly. So how many rides can you have? Okay, for those of you who said 58, no. $100 gets you up to 57.1. So you actually got to round down on this one. So you could get exactly 57 rides. And then, yeah, so you're going to have a couple cents left over? Yes. But you're not going to have enough change to pay for that 58th ride. Thank you so very much, guys. May God bless you and have a wonderful day.